Time travel has been done in the sense that you can travel into the future as fast as you like. Time has always been a fundamental dimension of our existence. It has served as the guiding framework for our daily lives and everything we've ever known. We have always perceived time as an unstoppable force, something that goes on no matter what. However, what if the very foundation we've built our understanding of the universe on is an intricate illusion? What if time, as we perceive it, is but a mirage, an intangible concept rather than an objective reality? Well, Brian Cox has finally shed light on the theory that time isn't real, and along with some data from the James Webb Space Telescope, the theory that once seemed too crazy doesn't seem quite as crazy anymore. So, join us as we unravel the mysteries together, discover the essence of time, and figure out what's really going on here. Brian Cox is a British physicist and a professor of particle physics at the University of Manchester, which means he knows what he's talking about. Born in Oldham, England, on March 3, 1968, Cox studied physics at the University of Manchester and excelled, earning a bachelor's degree in science. But he didn't stop there. He then went on to get his Doctor of Philosophy degree in high-energy particle physics from the same university in 1998. However, he's best known for being a science communicator. He takes complicated concepts from the scientific world and brings them to the general public, most often through the British Broadcasting Corporation, BBC. You may have seen his shows like The Infinite Monkey Cage and The Wonders of series, where he brings science to life in an entertaining and accessible way. Although this presence on television has helped popularize science, Cox has also ventured into writing to share his knowledge and insights. His works, such as Why Does E = MC Squared? And the Quantum Universe, dive into intriguing scientific topics, including the nature of time. In these writings, he explores the concept of time and raises the provocative notion that it might not be as real or straightforward as we tend to perceive it. This brings us to the theory: is time even real? Time is a mind-boggling concept that has puzzled scientists and philosophers for ages. On one hand, many people accept time as it appears to them, something that's always there, regardless of where we are or what we're doing, and that nothing can affect it. On the opposite end of the spectrum, deep thinkers argue that time as we perceive it is nothing more than an illusion. According to this mind-bending perspective, the past, present, and future might already exist simultaneously. It's like a cosmic Netflix binge watch, where every episode and every moment is already there, ready to be seen. What you experience just depends on where you are. This idea suggests that our experience of time flowing from one moment to the next is merely a trick our brains play on us. The way our brains process information from our surroundings creates the sense of time passing. It's like our brains are constantly taking snapshots of what's happening around us and stitching them together to create this illusion of a continuous flow. It's almost like we're living in a giant mental flipbook. Now, this might sound like something our brains really shouldn't be able to do. After all, they are just our brains, right? How can they make us think that time is real when it's not? Well, if you take a second to think about it, déjà vu does something similar. When it comes to déjà vu, it's not about time traveling or parallel universes, it's more about our brains playing tricks on us. Our brains are like supercomputers, processing tons of information all the time. Sometimes, though, they get a little overwhelmed and make mistakes. In the case of déjà vu, it's believed that our brains hiccup and malfunction for a split second. It's as if a wire gets crossed somewhere, and suddenly our brain sends a signal that says, "Hey, you've seen this before," when in reality, we haven't. It's like a temporary glitch in our memory or perception, making us feel like we're reliving a moment that has already happened. So, it's not that far-fetched to think that the brain could also be capable of holding up the illusion of time. That's why, in the world of physics, the concept of time has long been a subject of intense scrutiny and debate. Traditional Newtonian physics portrays time as an absolute and universal metronome, ticking away uniformly and providing a basis for determining the sequence and simultaneity of events. But Einstein's physics presents a totally different view, challenging the notion of time as an absolute and fixed entity. According to Einstein's theory of relativity, time is not a rigid and objective framework. Instead, it is malleable, influenced by the relative motion and gravitational fields of observers. This means that the sequence of events and their simultaneity can vary depending on the observer's point of view. Imagine two observers, one stationary and the other in motion. From their respective vantage points, they might perceive events occurring in a different order or even simultaneously. It's as if time becomes elastic, bending and stretching depending on the observer's perspective. This concept suggests that time is intimately intertwined with space, forming a four-dimensional fabric known as space-time. Within this fabric, the presence of mass and energy curves the structure of space-time, influencing the flow of time itself. This phenomenon, known as gravitational time dilation, highlights the interplay between gravity and the perception of time. Some physicists and philosophers take these revolutionary ideas even further, proposing that time might not be as real as it appears. They suggest that what we experience as the flow of time could be an illusion, a construct of our consciousness. In this view, the past, present, and future may coexist in a timeless and interconnected web, much like the way all points in space exist simultaneously. This mind-bending perspective challenges our conventional understanding of time and opens up myriad questions. Could time really be a product of our perception, a mental construct that allows us to make sense of our experiences? Is our experience of time merely a consequence of the way our brains process information? According to this perspective, the Earth's rotation, the orbit of celestial bodies, and even the transitions of atoms, such as those in cesium, play a pivotal role in shaping our perception of time. Think about the Earth's rotation, which brings us the cycles of day and night. As the planet spins on its axis, we experience the passage of time as the sun rises and sets. Our daily lives are really dependent on this natural rhythm, as we calibrate our activities to the progression of daylight and darkness. This regular, cyclical pattern serves as a fundamental reference point for our perception of time's flow. Similarly, the transitions of atoms, such as those in cesium, provide the basis for the precise measurement of time. Cesium atomic clocks, known for their remarkable accuracy, rely on the vibrations of cesium atoms to determine the intervals we call seconds. By calibrating our clocks to these atomic oscillations, we create a standardized and consistent framework for timekeeping. From the perspective of the "time isn't real" camp, these phenomena, Earth's rotation and atomic oscillations, are the building blocks from which our concept of time emerges. It is because we calibrate and synchronize clocks to these natural processes that we establish a shared understanding of the passage of time. In this viewpoint, time is not an intrinsic feature of the universe but rather something created and derived from the intricate interplay of cosmic events and the way we choose to measure and quantify them. This suggests that our perception of time is intricately tied to the very fabric of the universe itself, as we find ways to synchronize our experiences and create a sense of temporal continuity. If clocks were never created, humans might not have thought about the passage of time in the same way we do now. Perhaps things would have been totally different. Douglas Adams, the renowned author of The Hitchhiker's Guide to the Galaxy, also belongs to this school of thought. He famously said, "Time is an illusion, lunchtime doubly so." In his opinion, time is tied to how we think about history. Adams's viewpoint suggests that time is not an absolute and objective reality but rather a subjective construct that emerges from our experiences and the unfolding of events throughout history. In other words, time is a product of our perception and the narrative of events that shape our understanding of the world. From Adams's perspective, the notion of lunchtime being an illusion highlights the fleeting and arbitrary nature of our temporal divisions. Lunchtime, like any other moment in time, is a construct that holds significance only within the context of our societal norms and routines. It reminds us that our divisions of time, hours, minutes, and seconds, are human inventions, designed to provide structure and order to our lives. However, it's not just that. His point of view invites us to question the linear nature of time. The passage of history, with its progression from past to present to future, is seen as a product of our storytelling and the interpretation of events. Our sense of time's flow is shaped by the narratives we construct, connecting the dots of history to create a coherent timeline. If time is an illusion or a construct of our consciousness, this linear relationship between cause and consequence becomes entangled in a more intricate web of interconnectedness. In a timeless perspective, the distinction between cause and consequence becomes blurred. Events that we perceive as causes and their resulting effects are no longer confined to a strict temporal order. Instead, they exist as interdependent elements within a vast and interconnected network. In this framework, causes and consequences can influence each other in a bidirectional manner. An event that we might typically consider a consequence could retroactively impact its preceding causes. Likewise, causes may arise as a result of their future consequences. This intricate interplay challenges our intuitive understanding of causality and suggests that the relationship between cause and effect is more complex and nonlinear than we once thought. This theory, along with some recent data from the James Webb Space Telescope, has shown how we see into the past when we look into the night sky. The light that reaches our eyes from stars and galaxies may have traveled millions or even billions of years to reach us, meaning that when we look up, we're seeing objects as they were long ago, not as they are now. The distant objects we see might no longer exist in their observed form or position in the present, as their actual current states are hidden beyond the vast gulf of space and time that separates us. The JWST is equipped to peer deeper into the cosmos than ever before, and in doing so, it allows us to peer further back into the past. It has the ability to detect infrared light, which enables it to see the faint glow of ancient stars and galaxies that formed when the universe was still young. However, despite being able to peer into the distant past, the JWST can never provide us with a glimpse of the future. The limitations of the speed of light prevent us from observing future events directly, as the light from such events has yet to reach us,